Everybody, and thanks of course for the invitation. I really enjoy being here, and in the next minutes I want to give you a little bit of an insight in how photonics, optics and photonics can be useful in order to do or to realize quantum technologies that are mainly based on trapped atoms and ions, because this is like the specialty that we do research on in Braunschweig and Hanover. So first of all, of course, I would like to thank my colleagues, my group, and all the funding agencies that make our research possible. And to give you a little bit of an insight why integrated photonics, nanophotonics can be useful for quantum technologies. Here you can see a typical quantum optical setup as it is used nowadays. Yeah, this is from Munich, from a quantum optics lab, and as you may guess, this is not an optical storage, but all these optical components are there on purpose. Yeah? And we have quite a large variety of different elements that need to be utilized for realizing these quantum experiments. So we have lasers, we have optical resonators, we have isolators, beam splitters, mirrors, lenses, and whatever you can imagine. And these devices also cover a large variety, ranging from passive up to optical components, and also some hybrid ones. And as you all are probably familiar with, these experiments nowadays have ranges have sizes or footprints in the range of a few square meters, which of course is anything else but robust and compact. And in the next minutes, I want to show you some approaches how photonics can help us to miniaturize systems that use trapped atoms for applications in quantum metrology and quantum computing. And then I want to show you an example what we can do with trapped atoms for quantum sensing in terms of photonics, and also show you a little bit what the community is currently striving through. And afterwards, we also want to have a look how photonics can be suitable or useful for the next generation of ultra-stable laser resonators, which are a main working horse in many quantum applications. And nowadays, since the community also strives towards space applications, a miniaturization is or maybe really useful. So let's start with trapped ions. If we think of trapped ions for quantum computing, this platform provides a number of advantages compared to other platforms. For example, with trapped ions, we can achieve very large coherence times compared to other platforms, and we can also realize or achieve very